At the beginning of this module, we saw as to what we mean by the term modulation. As low-frequency signals cannot be transmitted over long distances, these are superimposed on high-frequency signals, known as carrier signals, and transmitted. This process is known as modulation. In radio broadcasting, two most commonly used modulation types are frequency modulation, FM, and amplitude modulation, AM. Let the carrier and the message, or modulating waves, be represented as follows. CMT equals AC sine omega CT, MT equals AM sine omega MT, where omega M is equal to 2 pi FM, is the angular frequency of the message signal. Modulated signal can be represented as CMT equals AC plus AM sine omega MT into sine omega CT. This equals AC taken common into 1 plus AM by AC sine omega MT into sine omega CT. That is, CMT equals AC sine omega CT plus mu AC sine omega MT sine omega CT. From the equation we find that the modulated signal contains the message signal. In this equation, mu stands for modulation index, which is the ratio of amplitudes of modulated wave to the carrier wave. Mathematically, mu equals AM by AC. If AM is larger than AC, the resulting signal will be distorted. This is averted by keeping this ratio less than or equal to 1. By using trigonometric relationship, sin A times sin B is equal to half of cos A minus B minus cos A plus B. We can write the above equation as CMT equals AC sine omega CT plus mu AC divided by 2 cos omega C minus omega MT minus mu AC divided by 2 cos omega C plus omega T. The terms omega C minus omega M and omega C plus omega M are known as lower side and upper side frequencies. The equation clearly signifies the modulated signal contains the carrier wave of frequency omega C as well as two sideband waves on its sides. This is illustrated graphically as the modulated signal's frequency spectrum. Interference of signals can be averted by keeping the sideband waves spaced out sufficiently so that they don't overlap.